Hello and welcome to the next developer diary for Heave. So if you're currently wondering what on earth is Heave, well, I've conveniently put a link to the previous developer diary in the description below, and I'll also give you a bit of an overview. So Heave is the first project that has been announced by myself and the others over at Freewheel Games. So Freewheel Games is a small studio that three of us have co-founded, and Heave is our first project that we've announced. It's a puzzle-based game for mobile devices, so Android and iOS ones, and in it you are controlling a cube with telekinetic powers as it works its way through various labyrinths that have increasingly intricate puzzles that you need to be able to be solving. And this isn't any old variety of telekinesis. This is telekinesis where Newton's second law applies. So if you try to use your telekinetic powers on something that is heavier than you move. If you try to use it on something that is lighter than you, then it moves. So that's a key sort of principle for it. So we're going to dive in and take a look at a pretty core section of it today. Now we are looking at it on desktop, so that means there is actually a bunch of debug UI that is present. So there is going to be UI that is going to be being replaced here, so just keep in mind this is not the final UI, it's stuff that we're using for testing. So this is one of our current levels, and key thing that we're going to be looking at in this developer diary is something that's at the very core of the game and that sort of binds everything together and makes sure that it actually is it's kind of feasible for things to work. So turn-based games are deceptively complex, potentially, in terms of their internals of how things work. Because in a real-time game, which, with that, something happens and all of the effects for it just unfold at that particular point in time. So it's quite straightforward. Something happens, you kick off the effects for it. But in a turn-based game, and in particular a turn-based game that features puzzles and where we want people to be able to figure out solutions for things, and the solution for something might not be as simple as just, a cause and then an action. It might be a cause and then an action and then a reaction to that and then a reaction to that you can get chains that are fairly deep. So the order that things happen in has to be predictable, has to be manageable, because otherwise what happens for the player could vary, and that's the last thing that we want. We want the player to know, okay, I go and take this action, then this particular thing happens. And if we take a look at this level, so the player, at the moment, it's the player's turn. Nothing is happening in the level apart from purely cosmetic things, so some rotations on some objects and a little bit of bobbing on these stepping stones. Now, as soon as I move, the way it works is the player initiates their action. That action chain, we refer to it as, gets fully resolved, and then the level acts, which the level can kick off chains as well. So when I hop, we see these blocks here move. So that's the level action taking place. And as I keep doing that, we get further ones actually happening. And those actions can be quite simple things like these blocks moving. But if I push this block here into the acid, so it's sitting there normally at the moment. Now, this is a good case of where the timing and the order of things matters. So we want the player from this location to be able to land on that block. So that means the player action gets fully resolved and then the level gets its chance to go. So if I pull over there, then I land on the block and then the block moves. If I wait here, then the block continues to move, so wait is effectively an action. And then we have further ones. So the mine here is a good example. These mines, something passing adjacent to them will actually cause them to activate. And like of this block here, if I pull that towards me, that mine is now active. And mines are actually a particularly intricate one because if I pull this block here, that block is going to pass over an active mine. It's doing that as part of the player's chain of events. not as part of the levels chain of events. Now, we want it that when a block passes over an active mine, the mine detonates. So that means that that block could pass over the mine as part of its turn, could also pass over it as part of the level's turn, because a block could be thrown by a mine. So we actually have to, in some cases for things like a mine, bring them earlier into the evaluation process. Because if I pull this over, then that detonates. And then I can now head over here if I want, which is not really going to help me because I've actually got myself into a situation where now I'm kind of stuck, which is fine. So, okay, we've got chains like of that can happen. So how do we actually manage those? So this is where we have the core of the system. We have this turn manager. Now, the version of the turn manager I'm showing you at the moment, this is actually the 4th iteration of it. And actually, iteration is probably putting it a little bit light. It's kind of like the 4th rewrite of it. It's something that it's taken us quite a while to get right. And this is also a good example of where this is a code system that's integral to it, but it's a code system that interacts very, very heavily with how the rules in the game are evaluated. So this is something that the development of this has actually been, getting it to a good version has been a lot of discussions between Tony and myself, sorting out the design and getting that really solidly grounded for it so that the rules follow through in the way that we want them to. So what we ended up settling on is we have these phases. So everything is broken down into phases, and the turn manager also controls the ticking of things. So we don't use the Unity update functions on objects, except for things like potentially very, idle ambient animations. Everything in the level, its ticking comes through this turn manager. So blocks indicate the phase they want to actually tick in. And so we have some pre-start ones because there's a bunch of level setup that we need to do. We might have an area where we need to place things in particular locations. We need to have various signals be sent. So we have a pre-start set that runs when the level spawns in so that we can actually ensure that those happen in a certain order so that we can place blocks. We have systems like our things for liquids. Liquids go through a system. We have the actual appearing of the level because the level appearance is animated. Then the player does any initial kickoff. Then we have these ideas of our core phases and transients. So a player turn, that's where it's waiting for the player to take an action. The transient phase is when we resolve any things that were set up, so any of the chains. So then we have things like motion. So these are level motion. And then motion transients, because something that moves could kick off other events. So the transients are how we resolve any cleaning up of residual items that need to be done. So we do movement, then we do damage. Post damage, well, you could damage something that then causes liquid to need to fill up into an area. As we saw with damaging block and then stepping stone, things like of that needed to change. We had acid fill up the area. So post damage is where we can do cleanup of that. We also, when we die, we want to play some animations. We want to have the player exit. We want to have the level exiting. So those happen in different phases. So by having this set up where we have everything in separate phases, it makes it very easy for us to add in new ones if we need to, but it also makes it very easy for us to sort of isolate actions in particular stages. So it keeps things fairly clean and fairly partitioned. Then things in the game can implement this tickable interface. So something like, for example, our liquid manager implements that tickable interface. So if I go to our liquid manager, we'll see we have all the way down, if we go to the actual manager, it implements tickable. when the level gets processed, it will go and register itself, and it registers in motion because liquids can cause flow, and it registers things in damage because in damage, it might need to rebuild an area. So then it's able to go and check, okay, well, in motion, it'll go through and kick off any expansion of liquid, stuff like that. Then it also can afterwards in the post-damage goes and actually does any rebuilding. And because expansion could happen, so this allows us to have things like the expansion take a bunch of time, and it doesn't let things progress. So the ticks can say, I have more work that I need to do, versus being able to say, I have no more work to do. So if they say they've got more work to do, then it doesn't leave that phase until it's actually finished that work. So the liquid manager makes use of it for things like that. Proximity mines, other ones can make use of it for checking the status of stuff. So then the actual turn manager itself, has stuff where, okay, we might need to easily be able to find the next transient phase, because if we're in the middle of the motion phase, we want to put any extra things that happen into the next transient. So this makes it very easy for us to kick off stuff into the next phase. And then the big stuff is these ones. So a phase has to actually be flagged as whether it's an instant one or whether it is able to actually run over time. So things like pre-starting systems, those aren't allowed to take time. Level appearance, player turns, those absolutely can take time. And a bunch of ones, most of our phases can actually take time. So they can run over a period of however long they need to. But some ones, we just don't need them to ever be instantaneous. And it will actually cause an error to be flagged if something tries to take longer when it actually shouldn't be allowed to. We also, for all of our transient phases, things that get registered just to avoid having, because it's very easy if you have to register for a tick to forget to deregister. So transient phases, you never actually need to register. They just automatically get cleaned up. So that makes that process a little bit easier from the code side. It's less prone to errors. And then the rest of the logic is pretty straightforward. There's a couple of little specific things for the actual player side of stuff. Just for the initial sort of setup there. But for the majority of it, what we're doing is if we're currently in the progress for a tick, we do some checks to see if a reset's been requested, because that could happen during a tick as a result of resolving a chain. And then we just advance the phase. We're checking if we need to clean things up. We're then going, and if we get to the player turn, well, we're done. So it can actually cascade through the phases until it hits the player turn. That's the intentional thing. So it will cascade through till it hits the player turn, player takes their action, and then it just runs through the phases in order till it gets back to the player turn again. So implementation-wise, it's actually not that complicated, and it's quite simple for us to be working with. The hard part was actually just getting to the stage where we actually had a good sense of what needed to happen. And the reason we went through multiple iterations was as we started to get implemented increasing complexities of blocks, as we started to get blocks in there that we would have those action chains that might go 2 or 3 deep, that started to expose issues in the previous versions. So this has meant, that sort of really was how we actually found the issues that we were running into. So when it actually puts the stuff in the tick phases, so when things register, it actually also does a little bit of extra logic there as well. So these phases get sorted so that the movement within a phase is also predictable. So as well as it going between phases in a very specific order, so that we know motion happens before damage, and with the exception being that something like a proximity mine can actually opt to say, nope, I need to go earlier in the chain. So some things like that can actually change their position in the chain if they need to. So otherwise, though, we potentially need to sort a phase. So if we look at that, this is another thing that we locked in sort of at the same time when we did this major rewrite was if you have multiple things that are in the same turn phase, how do we resolve them, and how do we resolve them in a consistent way? So what we actually do is we use what we refer to as typewriter prioritization. So the northwest corner, so top left effectively of the map, gets resolved first. We progress along that row, then the next row. And so each one we progress along that row through the columns, so we have a very consistent order that we know things will get resolved in. So it means we have predictability between phases and predictability within a phase, so that anything, the order that it happens in, it's reliable. We know when it's going to be. And that's a really important thing because, as I said, the key thing with sort of a puzzle game where you have interactions that go potentially several deep is people need to be able to predict what's going to happen. And those rules need to, there needs to not be lots of edge cases. It needs to be simple, and it needs to be something where people can internalize that quickly. Otherwise, the last thing you want is people getting there and being like, well, I don't know the order that this will happen in because sometimes it happens this way, sometimes it happens this other way. That's a terrible experience for the player and something we wanted to avoid. So that's why this is such a core part of the system, and it does literally drive the updating of pretty much everything in the game that you see goes through the turn manager. So very simple name for something that actually is on its 4th version and took quite a lot of iteration and discussion and collaboration to actually develop the rules for it to make it be the system that it is. But it now means that we have something that allows us to predictably know what's going to happen when. It means I know that I can hurl this block here and I can pull the block back, and I know the order that everything is going to happen in. So it means I know that if I send this block flying to the east, these mines, if I try and pull that block over them, they will actually immediately detonate. But if I wait, if I hop back here, I know that they will explode, and they'll do that before I've actually sort of pulled that block back. So I'm able to get that block back successfully now. And I know when I hop here, that will be armed. And then as soon as I go here, everything acts in the expected order. So I've got that predictability that things will happen in, and that's really crucial. And that was the major thing we were going for with this, is having it so that it was going to be predictable for the player so that they could understand and expect what was going to happen when they took a particular action. Thanks, folks. I hope you found the video interesting. If you're looking to find out more about Heave and see more things, we are going to be sharing things at times on our social media, and I've put the links to that below. And we've also got our main website up where we've got information on Heave, and there are going to be further developer diaries coming in future that will be talking about more things, which looking forward to sharing more of it, getting people seeing more of the game, because it's very cool. It's a lot of fun to play. Looking forward to it being in folks' hands. But until next time, bye.